Hello viewers, welcome to Famous Viewers Academy. In today's video, we shall be dealing with Introduction to Differentiation. Today, we are going to use two methods in resolving differentiation, which is the first principle and the power rule. We are going to start with the first principle, which is one of the most difficult methods in resolving differentiation. In fact, using first principle takes a lot of time. So the power rule is actually a modified rule to the first principle. Now let's talk about the first principle. How do we resolve the first principle? Sorry, how do we resolve differentiation using the first principle? We are going to check an increment in the y variable and an increment in the x variable. Let's say there will be a little increment in the y variable and also a little increment in the x variable. Let me assume I have a linear function, or let's use a quadratic function. Let's say I have y is equal to 2x squared. Y is equal to 2x squared. So what I'm going to do by solving this with the first principle is that I'm going to increase y by a small amount, and I'm also going to increase x by a small amount. Let's say that I'm going to increase y by amount of change in y. I will increase x by a small amount of change in x. So it means that y will now become y plus a little change in y, which is change in y. I will also do the same thing for x. This is 2. What has x become now? X will change with a little change in x. Then we have square here. So now, what are we going to do? Let's resolve this bracket first. We are going to expand this. Remember that in your mathematics, if I have, let's say, a plus b up square, it simply means a plus b bracket a plus b multiplying itself. So I'm going to do the same for here. I'm going to have y plus change in y is equal to 2 times, we have 2 of these brackets, x plus change in x and x plus change in x. So we are opening it twice. So what we are going to do here is that we are going to expand these brackets using the algebraic method. So we are going to have y plus change in y is equal to 2 or brackets. Now x times x, that's going to give us x squared. Then x times change in x, that's going to give us s change in x. Then if we multiply change in x times x, it's still going to give us s change in x plus change in x times change in x, that is change in x all squared. But I can just write it as change in x squared. But know that I mean change in x all squared. Now I'm going to cover my brackets. Now I know I can add up x change in x plus s change in x because they are the same terms. So s change in x plus s change in x, that will give us 2x change in x. So we are going to have y plus change in y is equal to 2 bracket x squared. X change in x plus s change in x, that is 2x change in x plus change in x squared. Mind you, it's change in x all squared. Now we can now open up this bracket by multiplying all through by 2. So if we multiply all through by 2, we are going to have, this is y plus change y is equal to 2 times x squared, that's 2x squared. Then plus 2 times 2 change in x, 2s change in x, 2 times 2, that is going to give us 4. Now 4x change in x plus 2 times change in x squared, that's going to give us 2 change in x squared. But don't forget what I said earlier, that this change in x squared, I mean change in x all squared. Now let's continue. First of all, we have to understand what we are looking for. We want to look for the derivative of this function by using the first principle. The derivative, that means we are looking for dy over dx. That is our goal. We are differentiating y with respect to x. Because if you look at this whole scenario here, you can't see anything like dy over dx. So we have to know our goal. Where are we going to? What are we doing? So what we are doing is that we are looking for dy over dx. And there's a general formula that states that dy over dx, which is as change in x tends to 0 of change in y over change in x. This is the main picture. So this is your goal. You are looking for dy by dx. But before you can get dy by dx, you need your change in y over change in x. So that is the first thing we are going to do. We are going to look for change in y over change in x. Now, I know that I can make change in y subject to formula here by taking y to the other side of the equation. So what are we going to have? We are going to have change in y is equal to 2x squared plus 4x change in x plus 2 change in x squared minus y. Remember, we'll carry y to that side. We are making change in y subject to formula. So from this point, we know what y was originally from the function. Y is equal to 2x squared. So we are going to replace y with 2x squared. Definitely, we have change in y equals to 2x squared plus 4x change in x plus 2 change in x squared minus, what is y? 2x squared. 2x squared. So notice something here, we have a positive 2x squared. Here we have a negative 2x squared. They are the same, but they are different. They are the same magnitude, but they have different signs. So we can fizzle out together. So we can cancel them out together. So we'll be left with change in y is equal to 4x change in x plus 2 change in x squared. We are almost there. Remember, our goal is to find change in y by change in x. So I already know that I have change y here. That means if I can divide both sides by change in x, therefore I can get my answer. So what am I going to do? If I look at the right hand side of this equation, I will notice that change in s is common here, is common here. So it's a common term to both this and this. So I'm going to factorize it. So I'm going to say change in y is equal to, so since change in s is here, is also here, I can factorize it, change in x, brackets. If change in s cancel change in x here, we are going to be left with 4x. 4x plus, if change in x, if you divide change in x squared by change in x, we are still going to have 1 change in x. So we have 2 change in x here, 2 change in x. Now if you don't understand this, this is what I mean. For example, if you look at this first term that we have here, this is 4s change in x. If I take 4s change in x and I divide it by this change in x that I factorized here, if this one cancels this one, I'll be left with 4x. That's why we use 4x. If you do the same thing here, you have 2 change in x squared over change in x. What will happen now? One of the change in x will cancel one here. We have change in x left. 2 times change in x, 2 change in x. So that's why we have that there. Now we are almost at the last part of this resolution. Now what we are going to do, remember we are looking for change y by change in x, so we divide both sides by change in x. Here by change in x. So that this will cancel this out. So what are we left with? We are left with change in y over change in x is equal to 4x plus 2 change in x. Now we're almost there. Now look at this. dy by dx is equal to the limit as change in x tends to 0 of change in y over change in x. Thank God now we have gotten our change in y over change in x. So we can plug it into this equation. We are at the last stage now. So we are going to have, using this equation, we are going to have dy over dx is equal to the limit as change in x tends to 0. What is change in y over change in x? Just notice change in y over change in x is 4x plus 2 change in x. So we are going to replace it. We now have 4x plus 2 change in x. Now this sign here, change in x tends to 0, we can replace change in x as 0. This actually means that as change in x is getting closer to 0, not exactly equal to 0, but in this case, we are going to do a direct substitution by replacing change in x to 0. So we are going to have dy over dx is equal to, so what this expression means that replace change in x as 0. That's the meaning of this limit as change in x tends to 0. So we are going to have 4x plus 2, what is change in x there? 0. So now dy over dx is equal to 4x plus 2 times 0, that's going to give us 0. So finally, dy over dx is going to give us 4x plus 0, that's going to give us 4x. So you can see it. We have a function, a quadratic function, which was y equals to 2x squared. We differentiated this function using the first principle, and our derivative was 4x. Mind you, might be confused with the terms I'm using. I'm using derivative. Now, derivative actually means differentiating. Differentiating, that's the meaning of derivative. Like say, give you a function and tell you to find the derivative, that means differentiate the function. So I have a function here, which is a quadratic function, and I ask you find the derivative of the function. I mean find dy over dx. That means what is dy over dx? So we have different terms we can use for differentiation. If I give you a function, I can say find the derivative of this function. I mean find dy over dx. I can tell you find y prime of the function. I mean differentiate. I can also tell you find f prime of x of the function. I mean differentiate. So differentiation can be given in different terms, but we have one way of doing it. So this is the first principle. And notice we just differentiated y equals to 2x squared, and our answer was 4x. But let's assume this was an exam condition, and you were given a question like this in objective, and you are using the first principle to solve this. That will take a lot of time. So that will take a lot of time. So you don't have to do this. The first principle, yes, is the first way of solving differentiation, but there are more modified ways that we can use in resolving questions in differentiation rather than using the first principle. And the best one is the power rule. The power rule, which is the modernized form of the first principle. So we are going to see how we can use the power rule. You notice that the power rule can just solve this question in 2 seconds instead of wasting all this time to get 4x. So how do we go about the power rule? So let's see the power rule. Let's see the power rule. What does the power rule state? The power rule states that if we have y is equal to ax to the power of n, this is the function. Y is equal to ax to the power of n, where a is a constant, which is the coefficient of x, and n is the power of x. It says that we can easily get the derivative of this function. That means we can get dy over dx. We can differentiate y with respect to x simply as a times n, then x. We remove 1 from the power. We subtract 1. That is n minus 1. That is all. So instead of us wasting all this time, we can easily use this power rule. This is the power rule. And what do we do in this case now? So let's use the power rule to resolve this question instead of wasting our time using the first principle. We are going to see, since our function is y is equal to 2x raised to the power of 2. So what will be our dy over dx using the first principle? Sorry, using the power rule, we are going to have dy over dx is equal to 2 times 2. 2 times 2 is what? 4. We will repeat the x. Let's remove 1 from the power. 2 minus 1. That's going to give us 1. So we know that 4x raised to the power of 1 is the same thing as 4x. So that's the answer. What do you notice? In less than 2 seconds, we get our answer. 4x. So this is how to solve differentiation using the first principle and using the power rule. The power rule is an alternative way of resolving differentiation. So for more exciting videos like this, please don't forget to like, to share, and to subscribe.